Hello. All right. So just a quick recap of the different shortcuts, different postulates that we talked about so far. So side, angle, side, or sorry, side, 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 angle, side, angle, angle, side. And then one that I haven't mentioned in the videos yet, I've mentioned it in class, I hope, but hypotenuse leg. So that just means we have a right triangle. So right triangle because there's a 90-degree angle. If I know that the hypotenuse is congruent and one of the legs is congruent to that one of the legs, and those two triangles are congruent. We cannot, under any circumstances, we cannot use any of these. These are all bad, especially that middle one there, but they're all bad. Never, ever, ever use any of those three. That's important for you to remember. Don't use any of those three. All right, so moving on to example 1. Are the two triangles congruent? So I know that N and P are congruent. I know that NM is congruent to PQ. And I also know that angle NLM is congruent to angle PLQ. So we have a side and then two angles. So this was an angle, this was a side, this was an angle. So now I have three things, so I can prove that the triangles are congruent. So I just need to figure out what order they're in. So this is the side that I use, this side right here, and this side over here. So this side, is it touching both the angles or is it in between both the angles? No, it's not. This is the side that's in between them. So that means that the side goes off to the side, so AS, postulate. So example 2, are the two triangles congruent? So again, this right here is very important. This little symbol, this arrow, these arrows, that is telling us that those lines are parallel. So I know that KJ is congruent to, oops, that's backwards. It should be NM. I know that LM is congruent to LJ. So far we have a side. Oops, that's not an angle, that's a side. So we got two sides so far. Since these are parallel, this angle and this angle are going to be congruent because of alternate interior angles. So they're on alternate sides, one's above, one's below of this transversal. So it's transversal because it touches both the parallel lines. And they're in between the two parallel lines. These are also alternate interior for the same reasons, and then these are vertical angles. So all those angles are congruent. So I can name any of these angles. So angle K is congruent to angle N. Angle J is congruent to angle M. So there's quite a few different postulates I could name. I could call it angle, angle, side. I could call it angle, side, angle. But either of those would work. So moving on to CPCTC. So CPCTC stand for congruent parts, corresponding parts of congruent triangles are congruent. So this is the way it works. So right here we have two congruent triangles. So hopefully you can tell me why those are congruent or what postulate I would use. So we got an angle and two sides. So the angle is touching both of the sides, or it's in between both the sides. So we'd say side, angle, side postulate. So since I know, because of the side angle side postulate, that the two triangles are congruent, that means all corresponding parts have to be congruent, which is what CPC/TC means. So I also know, even though it's not marked, I know that JK has to be congruent to NO. And I know angle N is congruent to angle J. And angle O is congruent to angle K. So just because they're not marked doesn't mean they're not congruent. Since I proved using the side angle side that they are congruent, the two triangles, all their corresponding parts have to be congruent as well. So the only time we use CP/CTC in proofs is after we've proven the two triangles are congruent. So moving on to the next page. Example 3, change the R to prove. So we need to prove angle P and angle R congruent. So first thing I'm going to do is write everything I know. So number 1, I know that PQ is congruent to RQ. I know that PS is congruent to RS. So the reasons would be given and given. So these are reasons. And then statements. And then I could also say, since this side is being shared by this triangle and this triangle, this side is going to be the same length for both triangles. So QS is congruent to QS. So do you guys remember what property says something is congruent or equal to itself? That'd be the reflexive property. Just going to put prop. So this side is congruent to itself. So now, well, we should always write the letters. So I use 3 sides. 3 sides are congruent. So hopefully that makes it obvious to you that we're going to be using the side, side, side. Oops, I wrote that in the wrong spot. So triangle PQS is congruent to triangle RQS. That's a triangle. So now I'll write the reason is side, side, side postulate. So since the two triangles are congruent, angle P and angle R, since they're corresponding, they have to be congruent. So angle P is congruent to angle R because of CP/CTC. So again, we can only use CP/CTC after we've proven that two triangles are congruent. Example 4. So again, I'm going to write everything that I know first. So Vx is congruent to Yx. And that's just given. XW is congruent to YZ. That's also given. And then what else do we know? So we're trying to prove that VW is congruent to XZ. So also given is XW is parallel to YZ, which is going to be important because if XW is parallel to YZ, then we know that this angle and this angle are corresponding. So if the two lines are parallel, these have to be congruent. So angle X is congruent to angle Y. So for now, I'm just going to write corresponding angles. Should write more there, but I'm just going to write that for now. So now I have used a side, and an angle. So all we need to prove that two triangles are congruent is three things. I have those three things. Let's see if they're in the correct order, because I can't use SSA. So let's see if that's the order they go in. Here's my angle right here. Is the angle in between the two sides. It's touching the blue and it's touching the red on both triangles. So that means that A is in between the two S's. So I am going to use side, angle, side, which I can use. So triangle XVW is congruent to triangle YXZ. By that sides, angle, side postulate. And then finally, since the two triangles are congruent, I know that BW has to be congruent to XZ because of CP, CTC. So anytime two triangles are congruent, all their corresponding parts have to be congruent. Finally, example 5. So it would help if I kind of drew this so it's not all together here. So they gave us that this and this is congruent, and then this and this is congruent. So that is just a given. So remember, proof's pretty much always the first reason is going to be given. Next thing they say is AC is congruent to AC. So AC is being shared by both of these triangles, so it has to be the same length for each triangle. So that's the reflexive property. Anything congruent or equal to itself is a reflexive property. Next thing is the ASA postulate. So what could we use the ASA postulate for? The only thing we can use these things for is to prove triangles are congruent. So we're going to have two triangles are congruent there. So this is the side we said was congruent to this side. So we got a side and two angles. So this side is in between the two angles, or it's touching both of those angles. So that means the S is going to go in between the two A's. Oops, they already did that for us right here. So triangle CDA is congruent to triangle CBA. I always forget to write that second triangle. And then they say that BC is congruent to DC. So we know that's true. We know this is congruent to this, or I could say this and this, because of CP, CTC. The triangles are congruent, so these two corresponding sides have to be congruent to each other. Next, they use the reflexive property. So notice that we're trying to prove these two triangles are congruent. So that would be this little area right here. So BCE and DCE. So they are both sharing this side right here. So for reflexive property, I'm going to say CE is congruent to CE. So this is a side. This was a side. And we already know the two angles are congruent from the given. So we got two sides and an angle. This angle, it would help if I drew these separately. So this angle is in between the two sides. This angle is in between the two sides. So SAS postulate. And that is it.